It says, in the diagram above, a bulb is lit by drawing 2.0 amps from 440 volts AC source. Calculate the cost of keeping the bulb on for 2 days at $0.4 per kilowatt hour. So quickly, we're going to do this. Now, let's write out our parameters. The current there is what? 2 amps or 2 ampere. The voltage there, which is AC volts, but we are not analyzing AC circuits now. The voltage is 440 volts. Okay, we should calculate the cost of running of keeping it running for 2 days. That's our time equals to what? 2 days. In calculating the cost of electrical energy, the time is usually expressed in terms of hours. So convert 2 days to hours. That would be 2 times 24 because 24 hours makes a day. So 2 days will be what? 2 times 24, which will give you 48. 48 hours. So we've converted that. What other parameter? Okay, the cost. The cost, or should I say the charge for the electrical energy is 0.0. This is dollar sign 0.4 per what? Kilowatt hour. So this is what they are charging per kilowatt hour energy. So now what we are going to do now is to calculate the total energy consumption. That's the amount of electrical energy this bulb has consumed for the 2 days it has been on. And the electrical energy, denoted by W, is given as what? Power times time. But there is no parameter here that has power. So we continue to analyze. Power also can be defined as the product of voltage and current. So in the place of power, we put voltage times what? Current. Then times time here. So we have voltage, we have current, we have time. Okay, so this is the formula we're going to use. We're going to use that electrical energy equals to what? Voltage times current times time. This is the one we're going to use. So let's substitute and find the electrical energy consumption there. So that will be 440 times the current there is 2 times the time. The time is 48 hours. 48 hours. So if you do this will give you 42,240. 42,240 watt hour. Because remember, here is power. VI represents what? Power. So the unit for multiplying these two is watt, while this one is hour. So the final unit for the electrical energy will be what? Watt hour. 42,240 watt hour. However, the unit for electrical energy is usually kept in kilowatt hour. See, kilowatt hour. So if you convert this to kilowatt hour by dividing it by 1,000. By dividing it by 1,000, you'll be having 42.24 kilowatt hour. So this is the total energy consumption of that light bulb. So having calculated that, the next step is to find out the cost. And here we have been told that what the service providers charge is what? They charge $0.4 per kilowatt hour. So 1 kilowatt hour of electrical energy, they are charging what? $0.4. So when you now consume 42 point that kilowatt hour, what will now be the charge? That will be multiply the two. So now the cost will be what? 0. Our dollar sign there, 0.4 per kilowatt hour times the total energy consumption there, which is 42.24 kilowatt hour. Then kilowatt hour cancel kilowatt hour, 0.4 times 42.24 will give you 16.896. So the cost is equals to what? $16.896. So what we have here is 16.9. So if you approximate this one, if you approximate it to one decimal place, that will be 16.9, option A. So the cost of running this bulb for 2 days is what? $16.9. Right.